Hi, welcome to the series on Word2Vec. In the previous few sessions, we talked about how we train Word2Vec and what are the optimization possibilities. So one of the method that we discussed previously was a hierarchical softmax. So we'll continue the discussion of optimization for a Word2Vec with one more technique called negative sampling. So essentially, what computational efficiency is a big question with vanilla Word2Vec, model. So in order to speed up the training, we have to optimize the way the softmax probabilities are computed. So one of the method that we saw was hierarchical softmax. In this video, I'll be talking about negative sampling here. Okay, so what's negative sampling technique? Let's take a look at it, what it achieves. Essentially, the Word2Vec neural net, the objective function, um essentially finds out the softmax probability of the target word, but here in negative sampling, what we do is for each of the positive pair, let's say the context word and the target word, that is called positive pair. For each of the positive pair, we will sample some negative pair as well. So essentially, we will build a binary classifier with these two sets of data. One is the positive pair, and the other one is the random, pair where the target word is just chosen randomly from the vocabulary. So that's the binary classifier. I'm going to explain how this binary classifier is going to work in negative sampling. So let's first understand what is negative sample and how do we choose negative samples. So the algorithm here during the training process for each positive training instance means the uh, context word and the target word combination is called positive training sample. For each of the training sample, positive training sample, we will also have small number of negative instances. And the objective of the loss function would be to maximize the probability of positive target word being predicted and minimize the probability of the negative instances. That's the broad idea or a macro idea behind negative sample. But how does it improve the process of training and how it helps in terms of faster training? So let's understand that process with some more examples. So for illustration, let's take the sample. Quick brown fox jumps over the lazy dog. So if this is a sentence, then the positive pair for window 2, for example, D is the word, like a target word. The surrounding words are going to be quick and brown. And similarly, if we look at some other example here, let's say jumps, jumps. So the surrounding word would be brown and fox, and over and the. So these are the surrounding word. Now this combination of target and the surrounding or the context is called positive pair. Now, the negative sampling here would be for each positive case or a pair, we will sample some small number of negative examples. So how do we choose the negative samples? Essentially, for one positive pair, we will have roughly about 4 to 5 or sometimes it could be more than 5, like 8 or 10. So there are some heuristics that I'm going to show it to you. Based on that, you can configure the algorithm to choose that many negative sample. This is again a tunable exercise. So with a lot of experimentation, we come to the idea of how many negative samples we want for each of the positive pair. For example, this is the positive pair, brown, and the context word is the quick, fox, and jump. This is one positive pair for brown. Brown is the target. Now, what we can do is a negative sample, brown, maybe apple. This is not part of the sentence, but part of the vocabulary, but randomly picked up. Brown laptop, which is not part of the sentence that we are talking about here. Brown and lamp. It could be any vocabulary word in the corpus. So if you look at it here, for each of the positive pair, we are generating few negative samples as well. So let's look at it in slightly more detail. For example, here, quick brown fox jumps over the lazy dog. The positive pair is brown, and the rest of the words here as the context word. So the context word quick and the target word is brown. This is the label of one. Why label of one? This is a positive pair. Now we would sample some random negative target words associated with quick, maybe king, and we label it 0. Similarly, quick and book randomly picked up, and that's 0 again. Some more negative samples, quick uncle, and the label is 0 here. Quick and laptop, again, label of 0. So now you notice we have two classes of data, two distributions. One is a positive case, and the other ones are negative samples. So essentially, how many negative samples we choose, that is again by Mikolov, the author of the original paper. It, he recommended, or the team recommended, the negative samples for smaller data set, maybe by between 5 and 20. For larger data sets, 2 to 5 negative samples is enough. I mean, the intuition is you have a large data set. That means lots of iterations and lots of epoch. And if you choose small number of negative sample, that will cover the entire, corpus. So now I mentioned that with this combination, we are going to be doing a binary classification, essentially logistic regression. So now the context word and the target word becomes a feature, and the label here becomes the outcome or target for the binary classifier. So now together with the positive pair and the negative samples, you have a binary logistic regression classifier. And the aim is to separate those two classes, positive classes and negative classes. So the loss function is pretty much the same that we have seen in logistic regression. So how many binary classifier in Word2Vec model with the negative sample? There are multiple binary classifier, one for each training pair, positive and negative. That means if you have 50,000 such samples, and for each sample, so when we say sample means combination of positive and the negative samples. So that's one sample or subset. So if you have 50,000 subsets, then we are talking about that many classifiers, or binary classifier. And each classifier is then responsible to distinguish the target word from the positive pair and the target words from the negative pair. And essentially, the model learns to predict the right target word given the context word. This is the underlying principle here. The objective function changes a bit with negative sampling. The traditional objective function is maximizing the probability or minimizing the error. But here now we have two different classes. So we will have to look at the loss function here. So the loss function for the target and the context, and loss function for the negative word and the context. Now here negative word has been given a label of 0. So we take the loss function construct in this fashion, which is like 1 minus the sigmoid. And for the positive pair is going to be log of the activation. Now, when you combine these two, that will give us the total loss function, and the classifier essentially tries to minimize the error. So intuitively, what it means is the classifier gains the ability to predict the right target word, which is a positive target word given the context. So that essentially is the idea here of negative sampling. How do we choose the value of k, or as to how many numbers of negative sample? Choice of k is not universally defined. There is no such optimal setting, but some heuristic guidelines are provided. So either you can go with the common value of k between 5 and 20, or you can use uniform distribution. Let's say your vocabulary size is 50k, so every word is equally likely. So this is a reciprocal of the size of the vocabulary. Sometimes you might want to configure the algorithm to pick the negative samples proportional to their presence in the corpus. But roughly, most of the time we experiment with some integer value, like between 5 and 20. Okay, so the hyperparameters in Gensim to help you configure for the negative sampling. So if you give a value integer for negative, and if it is greater than 0, that means negative sampling is going to be applied by the algorithm. If it is 0, no negative sampling is going to be applied. Similarly, there is another parameter called negative sampling exponent. That means if you use the exponent use, then it will apply the exponentiation. Let me tell you, if the frequency of the word is something, then you apply the exponential. Let's say this is 0.75, then that's the smoothing factor. Generally, this is set to 0.75. Not really required, this parameter. This is a little advanced setting. uh, if you just use negative setting with the value between 5 and 20 and repeat your experiment, you should be able to get the benefit of faster training. Now, so which one to use, hierarchical softmax, or do we use negative sampling? Again, the yardstick can be, if you have a large vocabulary, then go with hierarchical softmax. And if you're looking for really quick and fast training of the Word2Vec, use the negative sampling option. So let's take a look at the performance comparison when we use hierarchical softmax and negative sampling. Okay, so let's take a look at it. I'm going to be doing a basic Word2Vec. Then I will prepare a Word2Vec model using hierarchical softmax, and then another model with negative sampling, and we will try to compare. I'm not going to use a huge data set, just an illustrative small data set, and show you the difference in terms of the time it takes to train. I'm going to use the Brown corpus. The first setting is very easy. I mean, skip gram, no hierarchical softmax, no negative sampling, and very small number of iteration, which is 5. And I'm going to run the Word2Vec with the Brown corpus. And the time it takes is roughly about 25.36 seconds. This is a very small example. Now, what I'm going to do is now with the hierarchical softmax, so change your parameter, skip gram still, and hierarchical softmax I've set to 1. That means the algorithm should apply hierarchical softmax rather than complete softmax here. No negative sampling here. With this setting, I'm getting a slightly, reduced training time. Compared to 25, I'm having 21 seconds here. So this difference will really amplify when you talk about GBs of data. This one is pretty small, 1 or 2 MB of data here. Now, third model is negative sampling, skip gram, no hierarchical, but I'm choosing 5 as a negative samples to be picked up for each of the positive pair, and then epoch remains a small value. And here we get even better performance, 20.03 seconds, which is an improvement from the hierarchical softmax as well. So that proves that with this optimization settings, we get better performance. Let's do some analysis using these three models. I have saved these three models when we prepared each one. The first one is a basic one, then brown with the hierarchical softmax, and this is with the negative sample. So if we do some analogy, let's say king is to queen, and what is man and all that. So there are two analogy that we would like to perform. So this is a little function here, and the output is if king is to queen, and then the man is to thanks something here. So this is not a good result of the basic model, but this one gives quite appropriate. Man is to woman. This one is also giving a good result. Man is to woman. Okay. So this is a very illustrative example. Don't look for perfection. So example number 2 again, words to compare science, and you want to find out the similar word to science. And again, I'm going to be using all the three models here. For science, the basic model gives you clearing, which is really not much to do with science. But here, science and political science and religion, again, I mean, the data set is not really that that comprehensive to perform such analytical or text-based, analogy here. Anyway, so the point was to show you the performance gain in terms of time by choosing hierarchical softmax or negative sampling. I hope you like this Python code and demo. I will attach this code with a description. And the next topic going to be, yeah, so we talked about with the performance gains because of hierarchical softmax and negative. um, that's pretty much it. I wanted to cover in this video. In the next video, we'll talk about shortcomings of Word2Vec. There are some limitations of Word2Vec. We will look at each one of the limitations, and then we talk about some advanced word embeddings like fast text and so on and so forth. See you in the next video.